The question says in this RLC series circuit, R is 100 ohms, L is 0.16 Henry and C is 25 microfarad. So for what angular frequency of the voltage wave the current will be maximum? So we don't have to find the maximum current, but for what angular frequency the current will be maximum we have to find. So in order to do that, let's see the current at any point is given by the voltage at that instant divided by the magnitude of the impedance. The question is, I'm just looking at the magnitude of current and magnitude of voltage, and so magnitude of impedance, let's forget the angle because we are just looking at the magnitude. So Z is given by, as we know, R square plus XL minus XC whole square. Now when Z is minimum, the current will be maximum, of course, and that is possible since XL and XC, they have different signs. There is a angular frequency when XL will be XC, of course there is an angular frequency. So that is the frequency when the current will maximize. So this goes something like this, and omega is 1 over LC. Now if we do that, we will see, since L is in terms of Henry 0.16 and 25 microfarad, but it has to be in farad, so 10 to the power minus 6, and if we do that we will see we will get 500 radian per second. That's the angular frequency. So that's done, and this frequency is called, there's a corresponding frequency as well. This is called the resonance condition or the resonance frequency of the series circuit. So this goes something like this. If we draw the angular frequency, if we change the frequency and plot the current for various frequency, the plot will be something like this. I will draw maybe another one, and this one, this is for a greater less R, so R is increasing this way. The higher the R, the current is decreasing, the peak is decreasing and current everywhere is decreasing. And this one is the frequency when it is not changing, since this is happening only at R. So this is the resonance frequency. So when the XL and XC are the same, and also this is happening, the current is decreasing because at low frequency, when the frequency is low, XL is low while XC is high. Similarly, when frequency is very high, this is for low frequency, when frequency is low, high, then XL will be high and XC will start decreasing, because obviously omega L and omega C, 1 over omega C, so when omega is high this one will go up, and when omega is high this one will go down. But there is a frequency when they are equal, and that's the time when the current will maximum, because that's the minimum impedance condition. In all other cases the current will be less than that. So yeah, and of course at resonance frequency current is given by V over R, because Z is becoming R, since XL is equal to XC and they are getting cancelled.